Hi, so today I'm going to be talking about microservices and APIs and some risks associated with them, also with some mitigations. So I'll start with an introduction to APIs. I think I'm one of 3 presenters today talking about them, so we might as well have some sort of introduction to start off the day. And then I'll talk about microservice architectures, what they are, and why they're relevant to APIs, and then go into some risks and vulnerabilities, along with some final recommendations on how to deal with those risks and vulnerabilities. So what are APIs? At their core, they are a connector between 2 applications. So if you want to, say, access a song on a music streaming service, you will send a request to the API for that song, and it will send you a response back with the song that you requested, ideally. And APIs have a lot of uses in terms of the actual functionality of applications, but they also have an important use for security as well, because they act as kind of the middleman in between the backend data that people are accessing and the public that is trying to access your application. So they are important to make sure that people are getting not only the information that they are requesting, but also information that they are authorized to see. So there's a basic structure of APIs. They come in different forms depending on the type of API you're using, but one of the most basic has endpoints which have a specific function, specifically for things like on a music service for accessing a specific song, for a login service, or requesting a specific artist. And then you enter the parameter for the API. That is the specific song you might be requesting, the specific artist, the username and login for accessing whatever platform, and so on. So onto microservice architectures. Prior to about the early 2010s, the predominant design for new applications were monolithic applications. And they were applications that had all of the functionality in one giant code base. So everything from the payment system to the UI to the ordering system, login, everything was in one giant application, and that was connected to a database. And starting in the early 2010s, a more common new design was the microservice application design system. And this broke down the monolithic application into smaller components. So for things like a payment system would be one microservice, the login system would be another one, and so on and so on. And the purpose of microservices compared to the monolithic application was for flexibility. The monolithic application, if you changed one section of the code base, you then had to test the entire thing. And that took a lot of time, and it's not an efficient process. So microservices exist to make sure that you ideally can change one microservice, test it, and then deploy it, and not have to deal with altering all of the other micro applications in your network. So there's a level of flexibility that you don't get with monolithic applications. And also part of the microservice design is that ideally each microservice that needs data has its own separate database. And when it comes to APIs, both architectures will have APIs to interact with users that are using them. But the difference is that the microservices will also have APIs interacting with each other, which means that microservice architecture will inevitably have more APIs than the monolithic application. And this has an effect on the amount of risks in this type of architecture. And the direct communication between microservices may not be direct communication. There could also be some sort of intermediary, either the API gateway or a service discovery mechanism, which is a separate structure where all of the microservices register there, and then when they have to communicate, they talk to the service discovery registry. But regardless of the actual implementation, microservices do have to communicate in some way, and they will use APIs, which means more APIs in your network. So the risks of microservices. So there is an increased attack surface because of the increased number of APIs using this type of design, and also the increased number of databases that you are also going to have to protect. So how do you deal with this risk? Some recommendations: you can add redundancy measures to make sure that there isn't overload from all of the additional APIs in your network. You should maintain a thorough inventory of all of your APIs. This will help prevent shadow APIs and zombie APIs. And if you don't know what those are, shadow APIs are APIs that were created outside of the organization's regulation, like organizational policies. So most organizations will have some sort of process, which might include an approval process, design, testing, documentation. All has to be done before deployment, and that takes time. So what some developers will do instead of going through that process is they just won't, and they'll make the API and deploy it themselves. And there are a lot of risks involved in that. Like I said, it may not have been designed well, it probably wasn't tested or documented very well. And beyond that, you could have issues when it comes to logging and monitoring for that API, because a lot of organizations require that their APIs go through some sort of logging system, either using the API gateway or some other structure. And if you're deploying the API on your own, you may not be actually connecting those shadow APIs to those structures, which means not only are they probably not documented well, but they may not even be being well monitored, which creates a risk for your network. And then there's also zombie APIs. Zombie APIs are essentially APIs that have been forgotten by an organization. This most often happens with older versions. So you create a version, you launch another one 6 months to a year later, and then so on and so on. But you keep the older one up either for backwards compatibility reasons, or someone just didn't go back and decommission it. But whatever the reason, those APIs are still publicly available, but over time, they end up getting forgotten by an organization. And this is a problem because those APIs are not being maintained, they're probably not being monitored, they're not being patched, which means over time, they're likely to have vulnerabilities in them, and that could eventually cause problems. And there was some mention yesterday about APIs and how there was an analysis done that there were 30% more APIs in enterprises than most enterprises realize. And a huge part of having those excess endpoints are these types of problems, these shadow APIs and zombie APIs. And there are ways to find them if you do have them, but it's not a simple process, it's not a straightforward process, and it can be costly and time-consuming. So I recommend, to prevent all of that, just keep a thorough inventory of all of your APIs, preferably through some sort of auto-generated means. Next, configure thorough logging and monitoring. Like I said, if you don't have visibility into your APIs, a whole bunch of stuff could be happening to them, so make sure that you have logging and monitoring implemented, and also careful versioning and planning of your deployments. Each time you add a new API to your network, it's not only the time of making the API, but there's also all of the overhead structures associated with it. So if you're keeping older versions up, you are then adding more work for your API gateway, for potential service discovery mechanisms. All of the support structures around it are also going to have to continuously maintain all of those APIs. So just being strategic about new deployments will help make sure that your entire network doesn't get too overwhelming. Next, we have cascading failures. So one of the core purposes of microservices is the flexibility they provide. And that flexibility comes with the level of independence of the microservices in your network. But if they are too closely aligned with each other, then you can get something called cascading failures, which is when one of your microservices that is connected to another one that's potentially connected to another one goes down, and then they all go down, and you're going to have issues within the functionality of your microservices. And the concept that goes with this is called loose coupling. So microservices should be designed to be loosely coupled, which means they should be as independent as possible. You can't design the network to have completely independent microservices, but making sure that if there are dependencies, that those dependencies are absolutely necessary. That will help prevent cascading failures. So the first recommendation is to design with the goal of loose coupling, and this includes domain coupling, temporal coupling, and implementational coupling. And domain coupling is keeping all of your separate business domains separate, so things like your finance system, your HR system, your ordering system, all of those are separate domains, and making sure that those are as independent as possible. Temporal coupling is probably what you would think of when you think of loose coupling or cascading failures, which is when one microservice has to make a synchronous call to another one, that has to make a synchronous call to another one, and if one goes down, the entire chain goes down. And implementational coupling, an example of this one would be if you have two microservices that share a database. If you change that database, then you're changing the functionality of both microservices. So that's why ideally any microservice that needs a database has its own, but for resource purposes or other issues, you may not have that, but just being aware of implementational coupling when you're designing your network. Next is creating documentation to show which microservices are coupled in your network and what type of coupling it is. That will help with testing once you're in the testing stage and potential troubleshooting down the line. You can also conduct unit testing, integration testing, and end-to-end testing to confirm the correct functionality based on the design that you made in the previous step. And also preventing single points of failure in your network will help make sure that cascading failures don't become a huge issue if they ever occur. And next we have third-party software integrations. So it's common to add third-party software to APIs or any other parts of applications, be it commercial code, open source code, or code library. But anytime you add third-party software, you could be potentially adding vulnerabilities into your API, because even the best code can have vulnerabilities in it. So to mitigate that risk, you can perform risk assessments that might help prevent adding potential vulnerabilities into your new APIs. Staying up to date about new vulnerabilities in the third-party software you've put in previously deployed APIs, because just because the API doesn't have vulnerabilities when you launch it, which hopefully it doesn't mean down the line it might not. So keeping up to date with new vulnerabilities that come out with your software integrations will help with this risk. You can do automated vulnerability scan on the third-party software if that's possible. That's not always possible. Some third-party software does not allow for vulnerability scans, but if you are able to do that, I would recommend it. And also consider implementing a software bill of materials framework that has been mentioned so many times over the past couple of days, but that could help secure your supply chain and make sure that there is at least documentation of all of the software that you are putting into your APIs. So onto vulnerabilities. So this presentation is in large part from a paper that I wrote about API and microservice risks and vulnerabilities. And I showed you the risks, and the paper talks about a lot of vulnerabilities, more than I have time to discuss here today. So when I thought about what single vulnerability or what subset of vulnerabilities I should talk about, I came to the conclusion that the most important ones would be authorization vulnerabilities. As of 2023, 3 of the top 5 vulnerabilities identified by OWASP for APIs were authorization related, so they're probably the most important subset to talk about. So I'll be going through those three. So the first is broken object level authorization, or BOLA. This happens when someone that is authenticated into a system is able to access an object that they should not be able to access. So say, for example, in your banking system, you should be able to see your own bank account, but if you can change the parameter in the API and view somebody else's bank account, then that's a broken object level authorization issue. And most often, this vulnerability is associated with the API parameters. Not always. There are ways to have this vulnerability that are associated with other parts of the API, but most often, it does come with the parameters. Next, we have broken object property level authorization. It is surprisingly difficult to say, and even the acronym BOPLA is very clunky, but it's not as complicated as it looks. This vulnerability essentially means that the API is giving out more information about an object than it should. So say, for example, you're on a university webpage and you're using their public API to view all of the students that have graduated that year. Some reasonable information for that API to give out would be the students' first names, their last names, and their major. But if that API also gives out their email, their birthday, and their physical address, then that's more information than you should be seeing. And that is a broken object property level authorization issue. And the root cause of this vulnerability is the properties within each object not being protected. So for a student, for example, the back end will have a bunch of fields about a student, but only a certain subset of those fields should be publicly available, and the rest should be protected. And if the API isn't programmed to only take what should be the publicly available information, then you're going to reveal excess information. And you can see how this vulnerability, along with the last one, can easily lead to privacy concerns. And it can also lead to just revealing too much information about your network in general. So say if this vulnerability exists and someone is able to access an object that tells them the username of the admin account or the location of a sensitive file, they can then use that information for nefarious reasons. And finally, we have broken function level authorization. This one is when a user is able to modify or delete data that they should not be able to modify. So say you're a teacher, you should be able to modify your students' grades. If you're a student, you should only be able to view them. But if a student is able to modify their own grades or anyone else's grades, then that is a broken function level authorization issue. And this vulnerability is most often associated with the endpoints themselves. Again, not always, but oftentimes, once you access certain endpoints, you can do the modifications from there. So this one is more closely associated with endpoints themselves. And also, another common example of this vulnerability comes with admin endpoints. So organizations will often have an admin endpoint where they can make alterations in the back end, and it should obviously only be accessible by the IT team at that organization. But if it becomes publicly accessible, then it often lets the public make changes to the network that they should not be doing. So that's the broken function level authorization. So some overall recommendations, if I had to distill all of them down to a few things, I would say, first and foremost, keep a thorough inventory of all of your APIs. I don't think much of the rest of the recommendations mean that much if you don't have a good idea of all of the APIs in your network. Also implement static and dynamic testing of all of your APIs, and check authorization vulnerabilities, because, like I said, APIs are kind of the middleman between the backend and the users, and they're there to help make sure that only the information that the users should be accessing are accessible. Yeah, that's it.
So regarding the third vulnerability that you mentioned, I don't remember the acronym.
Broken function level authorization?
This one, the approach I'm familiar with is like token-based, like claims-based authorization, right? Where someone authenticates with the system, the security token they get back lists, the operations they're authorized to perform. So it seems like, is that industry standard? So if that's the case, then this seems like it should be a solved problem, or is that not really solving this issue in all cases?
No, this issue still very much does exist. And I think it also has to do with just the role-based access control in general. Those are not always accurate, so this issue is also closely related to that one as well. But yeah, it is unfortunately still an issue.
You're right, though. Like a claims-based system is only as good as if those roles are accurately mapped to these privileges.
I have a potentially unrelated question. I don't know if anybody else will talk about it, but when it comes with APIs, I made a note about logging in specifics. Have you ever come across logging as particularly a vulnerability? Is that something we all need to be concerned about? I have logged countless access tokens in my day.
Logging, like the
Like when I write somebody's login, what's like Bob logged in with access token XYZ, right? So for example, I've done that myself more times I can count. But logging is such an important attack factor that I don't see it mentioned too much. Does that ever come up? Is it in your paper? Maybe I could read about that. Is that something that you've identified?
So you did say logging, right? So I did mention with the, which vulnerability, or which risk was it? Yeah, configure thorough logging monitoring, including logging authentication failures and input failures. That is.
Log the authentication success or failure with a token. Yeah, sensitive data. Yeah.
Oh, logging.
Like your password is 1234, right? Like McKinley logged in with password 1234.
Yeah, so you could potentially log that type of information too, as long as you are keeping that information, like the logs, secure as well. Or you can obscure that type of information if you don't want the actual passwords being stored. But I don't think that's necessarily part of the logging and monitoring efforts that I was mentioning.
Thank you for this presentation. This is really it's useful and enlightening stuff. And my question is, do you find in your own research that organizations specify these APIs, that they have well thought out rules for their construction, or is it all just kind of one-off? And is there engineering discipline applied to these in general?
I feel like there's as much as is applied to, actually, I wouldn't say as much as applied to most applications, probably a little bit less for APIs, because they are very easy to create. And like I said, a lot of times people tend to make them and deploy them on the fly because for easy connections to things. So yeah, there's probably a slightly less organizational policy around them than there should be. But yeah, I don't know if that exactly answered your question.
Well, these are customer-facing applications, and if you're an organization with APIs that are critical to your success, gee, there ought to be some engineering and some upfront specification of these things. The vulnerabilities that you showed are fairly simple to explain and avoid.
Yes, they are. Especially the first one, the parameters. It's the top vulnerability for a reason. It's very easy to just change parameters and mess with things. So that is why API security is important.